So, I'm going to give you a course or lecture about cross-site scripting. My name is William Paavolainen, and here's a bit of background. So, like I said, my name is William. Nice to meet you all. And I work as a cybersecurity solution architect at Xamk, which is Southeastern Finland University of Applied Sciences. Also, I regularly host and participate in CTF competitions. Those are Capture the Flag. Those are, in case some of you probably might not know, those are a cybersecurity-centered, well, gamified competitions, let's put it that way. And I also do bug hunting and platform development, both of those quite regularly. That's it for the background. Let's get to the meat of things. So first things first, table of contents. What are we going to go through here? First, let's discuss a bit about what is cross-site scripting. There are a couple of different types or subtypes of cross-site scripting. We have reflected, stored, and DOM-based. More on those later. Then, after we know that, we are going to move towards impact. What kind of impact does cross-site scripting have, or what kind of impact can it have? Then we are going to look how to find cross-site scripting vulnerabilities and how to prevent them. And last but definitely not least, we have some real-world examples for you. So this is what's it's gonna be today, and let's get right to it. So what is cross-site scripting? Well, a common abbreviation for it is XSS, so cross-site scripting XSS, and I'm probably going to use that abbreviation more than the full name for it. It's a common injection type attack that is focused on web applications. So malicious scripts are injected into otherwise spinning and trusted websites, and attacker can use a web application to send malicious code to a different user of that same web application. That's basically the gist of it. Fairly simple concept, but extremely common. So, like I said or mentioned earlier, we have a couple of subtypes. We have reflected, stored, and DOM. So reflected is when user input is reflected back on the response. More on that later. Then stored is basically the same as reflected, but the input is stored somewhere on the server. Then we have DOM, which is document object model, and that doesn't necessarily require a request/response from a web application because the data flow doesn't leave the browser at all. But we are going to expand on those on the later slides. And lastly, it's fairly easy to exploit. I'm not making a claim that there cannot be hard XSS vulnerabilities to find and exploit. There most certainly is. But most commonly, the mistakes seen in the development of web applications, people just haven't thought the process through and accidents happen. We are human after all. So it's fairly common injection type vulnerability. Here's a table from OWASP's website. There we have stored and reflected XSS, and we both have server and client side types. And that DOM-based, which we are going to talk about as well, it's a subset of a client side cross-site scripting. If you don't understand any of that, no worries. We are going to look examples through all of them. And then we have the latest OWASP top 10 list. And there you can see at the number 3, there's injection. It includes all kinds of injections like SQL injections and such. But the last iteration, XSS had its own listing there. I think it was at number 7. So it's very, very common vulnerability. But yeah, let's go to reflected cross-site scripting. So reflected XSS occurs when an HTTP request is sent to an application, which then includes the data within that request in its response. Might sound somewhat confusing, but all in all, a very simple concept. So let's take an example. We have a website. Let's call it example.com. We have example.com that has a search bar. We use that search bar and we query a chair. We are looking for chairs. Maybe this website sells chairs. Who knows? Then we see the exact word that you searched for, in this case chair, appears in the resulting page. So now we have searched for a chair, we see that the word chair appears on the website, and then we try to modify the query a little bit. We type in that abomination. So we have script tags, so less than script and larger than or greater than. Then we have alert, test, and then we close the script tags. So we are trying to inject JavaScript into that search function. And what happens then? Well, if it's vulnerable, an alert message with a word test will appear on your screen. Now we start to think, okay, if I can run any JavaScript function that I want, I can basically write any amount of JavaScript code. Well, I can also run that code or execute that code in someone else's browser. And that's the thing. You write your own code and execute it in someone else's browser. And that's kind of alarming, to say at least. But now you have, let's say you created a keylogger in JavaScript. You can most definitely do that. And then you send that link to one of your friends or an unsuspecting victim. Then that victim clicks the link, goes to the website where your nasty payload is located, and the JavaScript payload gets executed within the victim's browser. And that's how you exploit, or how people exploit XSS vulnerabilities. Here's another example. Now this is a copy of a random Finnish website that I found, where you can search for some kinds of cars, and it looks like this. So it's a copy of this website, and there's, if you look at the URL, there's autohaku.php. That's basically carsearch.php. And then we have register, which in Finnish is called rekisteri. And as you can see, we don't have a search parameter there. So our register parameter is empty. There's nothing there. But if we put something in there, something like that, again, script tags, alert box, then we write XSS test and close the script tag. And this is what it looks like. This is the alert box that I was talking about. It says basically what we want it to say. But we can also try to fish other people's cookies or login credentials through the usage of same methods. And it will be way more stealthy because the alert box will be, of course, emitted from that payload. So it can be very, very severe, as in the consequences. But it also can be basically nothing. But more on that on the impact part. But that's how you do it. That's the most common, or perhaps the most basic way of exploiting cross-site scripting vulnerabilities. Then we have stored. It's basically the same as reflected XSS, but instead of the payload being reflected as part of the resulting response, like we saw earlier on that example, it gets stored somewhere within the application, or rather the backend of the application, somewhere in the server or wherever. The payload also could be injected to virtually anything where the user has write permissions. For example, username, contact details, or email, or wherever you can type something, there can be an XSS vulnerability. And next, payload could even be executed from a monitoring application that displays packet data. For example, if you have a secure operations center that monitors all the data that goes through your company network or something like that. Some sort of logs or whatever. If the application that is used to monitor that data is vulnerable, it can also trigger the payload. So it gets stored somewhere. That's basically the point of this. What does it look like? Well, I made my own very basic chat program thing, web application stuff, I don't know what to call it. But basically you can type anything and click send, and it gets stored in a server, in this case a MySQL database, and then it shows on the web page. That's it. And this is what we are trying to do. Exact same thing as we would do in the reflected one. So script tags, alert, and then we try test 2. And now anyone who goes to that website will get the alert box. Every single one. Even if they have a link or not. Everyone who visits there will get that. So this is a very effective way to spread malicious code to people. And third, we have DOM-based XSS. DOM is Document Object Model. And what that means is that all of the nodes of a basic web page are included in the DOM. There's something called a DOM tree, which would, in HTML context, it would include basically everything from a web page's source that you can see. There's HTML tags, then we have head tag, title, and so on and so forth, and body and all that. And those are included in the DOM. And DOM-based XSS could often look very similar to a reflected XSS exploit or vulnerability, because often they have also URL parameters, like we saw earlier on the examples. It also does not necessarily require the payload to be sent within a HTTP request, because the data flow does not leave the browser. So we don't necessarily require a request in between or response. And we are going to look through examples of this as well, and hopefully that will clear something up. But DOM-based XSS can also contain multiple sinks, that they are called. We have sources and we have sinks. Sources is basically where we type our nasty payload into, or rather that sends our nasty payload to the next step. That's called a source. And sink is what displays our nasty payload on the web page. And that's basically a fairly simple concept. And here's a short example. Let's consider this piece of code. There's a vulnerability right there. And this is what we see. So above we have our source, and below we have what we see. So we insert our input in the input field that we see. For example, if we type in test, the web application will execute console.log and test, so it writes the word test in our console. That's exactly what it does. And our mission is to escape that function and make our own function. In this case, we use alert. This is gamified XSS, and we are going to look more closely a bit later. But as you can see, we can escape existing functions, which is how XSS is commonly often exploited or used. In this case, we have the console.log. We escape that. We run our alert with a value 1, and that's it. We win. We won't get an alert box in this case, because this is my own self-made application, and on the development phase, it got quite irritating to see those hundreds and hundreds of alert boxes, so I just made it so it writes win instead. But that's basically DOM-based. There's no request or response in between, so when you type, you see what happens. Then we have impact. So typical exploitation objectives that can be achieved by XSS include impersonation. We can also capture login credentials or cookies. We can implement more traditional malware functionalities from Trojan's keyloggers, for example. And of course, defacement. So those are possible impacts that we can have. But honestly, the sky's the limit. Whatever you can write in JavaScript can be executed in someone else's browser. And if you ask me, at least personally, I would not want someone else's custom code executed in my own browser, whether on work or home, just because I visited a quote-unquote trusted website.